So, we're talking about the sides of triangles today. Um, if I have these three sides for a triangle, is it possible to make a triangle with these three segments? Can I make a triangle with these? These are the lengths, by the way, 5, 3, and 10. Can I make a triangle with those? Okay, even if I go completely flat, will a 5 and 3 make it all the way across? No. So, what can I say about any two lengths of a triangle? They have to equal the base? Okay, what if I made this one longer to like until it was 5? Can I make a triangle out of that? Okay, if I made them 5, they could stretch across and reach to be long enough to reach across this side, but would it be a triangle? No, it would just be a line, right? So any two sides of a triangle together have to be what? Greater than the third side. So if this was like 5 and 7, then that would reach far enough. If it only reaches 10 across, if they only add up to 10, they would just make a straight line. But if they're more than 10, then you can actually make a triangle out of it. You can raise them up. Does that make sense? So, any two sides of a triangle have to, together they have to be longer than the third side. If they're not longer, they won't reach. Like 3 and 5 would not reach across a gap of 10, even if you made them go straight towards each other. If they're the same length, they still wouldn't make a triangle, but you could reach across, but it'd just be a straight line. But that's not a triangle, still fail. So any two sides of a triangle have to be longer than the third side together. So basically, if you look at the two shortest sides of the triangle, is it more than the longest side? So is like 4, 6, and 8, is that a possible triangle? Yes, because 4 plus 6 is greater than 8. Is 4, 6, and 10, is this a possible triangle? No. 4 and 6 would only be long enough to reach across that 10, but it wouldn't be enough to move away from the 10. As soon as you start pulling them up, they're going to move far away from each other, right? So they could reach across, but that wouldn't be a triangle, it'd just be a line. If you started pulling them up to make a triangle, they wouldn't touch each other. Yeah, so this is not a triangle, it's not possible. Or 4, 6, and 12, definitely not possible. They wouldn't even be long enough to make anything. So, you guys got this rule? Clear as mud. Alright, that's not quite everything, that's kind of like half of it. Let's see. I don't like what they call these things. Not a big fan. They call it the hinge theorem, which I get. Alright. So let's say we have two identical alligators. They look kind of the same. Ish. Okay. Pretend those are identical. So let's say this alligator opens its mouth at a 70-degree angle. This alligator's mouth is only open at a 45-degree angle. Okay, what can we say about the gap between its jaws here and here?
45 angle was smaller than
Right.
70.
Yeah, this one definitely is gonna be a smaller gap, right? So, but we only know those if they have the same size jaws. Because if we have a tiny little alligator, even if it's open wide, this side right here is gonna be small. So if we know the jaws are the same, so side, but the angle between them is bigger or smaller, then we know the side opposite, that's gotta be bigger or smaller. Does that make sense? So the old book called this side angle side inequality theorem. So you guys remember we used to use side angle side to prove triangles are congruent, right? Side angle side congruence. But this one, the angle is not congruent. We just know the angle. We know one's bigger than the other. Side angle side inequality says if you know the two sides, the angle between, two sides are the same, but the angle between is bigger, then the side across from it's bigger. Or if you know the two sides are congruent, but the angle is smaller, then the side opposite that angle is going to be smaller than this triangle. This book calls it the hinge theorem. You guys know what a hinge is? Yeah. It's what the door, it's these things.
Oh, really?
Yeah.
Oh, okay.
The door opens and closes on a hinge,
Yes.
and that changes the angle between the door and the wall. So anyway, they're thinking of this like a hinge, like open wide, open small. So I just think of it as alligator mouth. Where's the alligator mouth? This one's open wide, this one's open small, like that. And yeah, that's the other half of the assignment. Okay, that's a little bit of a mess. Let's go ahead and try. So did you guys get the assignment over 1 through 29? Skip number 17. Number 1 on page 238 says attempt to sketch triangle ABC with the given side lengths. Either classify the triangle by side length. So if it makes a triangle, what kind of triangle is it? So is it like isosceles, scalene, equilateral, whatever? Classify the triangle by side length. Identify the point that lies between the other 2 points. That means if it makes a straight line, like it's not big enough to make a triangle, we're supposed to say the point in the middle. I'll help you when we get there. Or state that the segments do not meet. State that the triangle wouldn't even be able to touch. Okay, so 1, 3, and 5. There's kind of an example of each here. You really need your arm there. You think she's gonna steal it?
Well, I can't. I'm afraid it's gonna like fall through or something. I don't know.
It's not gonna fall through. Okay, number 1. So AB is 4, BC is 7, AC is 5. So does that make a triangle? So if you look at the smaller 2 sides, are 4 and 5 big enough for the 7? Yes. 4 plus 5 is bigger than 7.
Oh yeah.
So, okay. So we have a 4 and a 5 and a 7. Looks something like this. That's possible. What kind of triangle is it? Scalene. So not only do you need the sketch, you also need the scalene. Well, if it makes a triangle, you gotta say what kind it is. And if it doesn't, then you have a couple different options. Well, there's one example of each on the odds. So let's see. Number 3. So we got a 5, a 10, and a 5. Can a side of 5 and 5
No,
go with a 10?
no,
No. What would happen?
it wouldn't touch.
No, it would touch.
It'd make a straight line.
It'd make a straight line. Because 5 gets you halfway there, and then the other 5 gets you halfway there. So, let's see, they called the 5s AB and AC. So basically, it would look kind of like this. So they wanted to like say what point would be in the middle. So here's what they put, BAC. A is between B and C, that's what that meant. It would make a line, not a triangle. Okay, number 5 says 5, 1, and 3. Can the 1 and 3 make a triangle with 5? No, not big enough. So in our little picture, is, 1's not very big. It's something like this. So segments don't meet. Not long enough. So on the evens, I think there's one of each also, but it's in a different order than the odds. So there's one actual triangle, one straight line, one where they don't even touch at all. Alright, number 7, kind of the same thing. State whether attempting to construct triangle ABC with the given side lengths would produce a triangle, collinear points. What did collinear mean? Same line. So they make a line. Or segments don't meet. Pretty much same thing. They don't ask us to make a sketch. So on number 7, can the 8 and 4 sides go with the 12, make a triangle with 12? No, what would it make? Straight line. So they put collinear points. Is that 2 ends or 1? I always forget. 1 end. Okay, on number 9, can the 8 and 7 and 4, can that make a triangle? So you look at the two smaller ones, is 7 plus 4 bigger than 8?
Yeah.
Yes, so it does make a triangle. So just put triangle. It doesn't ask us what kind on this part. It would be scalene if they did. Number 11. Can the 50 and 50 make a triangle with 101? No. 50 plus 50 is 100. They're not long enough, so segments don't meet again. Number 13, use the hinge theorem. So this is the alligator mouths. The hinge is like the jaw of the alligator. Or its converse to compare, oh shoot, I didn't talk about the converse. Okay. I need to talk about the converse really quickly. Look too much the same. Alright, so the other one I called side angle side, this one could be called side side side. So it's still alligator jaws, the difference is I don't know the angles. So notice these both have a 6 and a 4, So those are the jaws. Those are what you're looking for, the two matching jaws, like the twin alligators. This alligator's mouth is open 5, and this alligator's mouth is open 3. So guess what we can say about the angle between their jaws here? Yeah, this one, the alligator would have to be, I don't know what it is, but I know compared to this one, it's bigger. Okay, so this is called sometimes side-side-side inequality theorem. The book calls it the converse of the hinge theorem. Anyway, so we know something about all 3 sides. 2 of the sides are the same, those are the alligator jaws, and the third sides are different. And the third side, if it's a bigger side, it goes across from the bigger angle. Smaller side goes across from the smaller angle. Okay, the hinge theorem, where the side angle side, is where you know the angles. And you can say something about this. All right. Now, back to it. Number 13. Okay, do you guys see the alligator jaws? It's the 4 and 7. Yeah, the 4 and 7. So we're supposed to say an inequality, by the way. I didn't read the whole thing. Say an inequality that we know is true. So angle A is bigger than angle X, however. So alligator on the left, his mouth is open wider than alligator on the right. So what must be bigger than what? WJ, that 50 degrees opens up to WJ, is bigger than what? BE. So that's what we're going to put. WJ greater than BE. Fifteen's kind of a tricky question. Okay, so you see the 5 and 3, right? Those are the alligator jaws. The alligator on the left is open 90 degrees at angle B. The alligator on the right is open, well, they don't tell us, but what do we know about angle Q? It's got to be less than 90, because it's in a triangle, there's already 90 in the corner. It's acute. So the alligator on the right is open smaller than the alligator on the left. So what's bigger than what? AC is bigger than PR. Okay, we didn't use the side version, darn it. So I probably should do one of the evens then.
16.
Okay, so on 16, those are both, what kind of triangles are those both? Isosceles. And both of those marked sides are 5 and 5. So those are the alligator jaws. 5 and 5 on the left, 5 and 5 on the right.
Okay.
The alligator on the left is its mouth is only open 3, whatever. The alligator on the alligator on the right's mouth is open 6. So what is bigger than what, or what is?
RN is greater than GQ.
It would be HQ.
Okay, you can't use sides that have already been labeled. Yeah, 3 is smaller than 6 or whatever. What'd you say, Isaac?
Would it be HQ instead of GQ?
No. HQ and GQ. We know HQ is 5. They tell us that, basically. We need something that they didn't tell us.
GH? No, wait, no.
Angles. Angles. We know all 3 sides of both triangles, how long they are. The alligator on the right, if you look at the jaws, are 5 and 5. But the gap between the jaws is 3 between the mouth. The alligator on the left, or did I say right? The alligator on the left, its jaws are open 3. The alligator on the right, its jaws are open 6. So what do we know about the angle between the jaws? Angle H is smaller than angle D, yes. That's it. So we know something about the angle. You can't use the sides because they tell you what the sides are. We don't need you to tell us that 3 is less than 5. We need something that's missing, the missing fact, which is angle H is less than angle D. Or angle D is greater than angle H. All right. Kind of the same thing, just using a different picture. 19. Use the hinge theorem, or that's the alligators, or a converse to compare the given measures. So, probably better draw this because we're gonna have to label it. It says A, B, C, D. It says AB is 5. BC is 5. Oh, I'm looking at the wrong problem. That's number 18. AB is 9. BC is 8. AC is 6. And DC is 9. Ooh. Youch. Okay. Well, what else do we know in this picture? Yeah, BD is the same in both. So, do you guys see the jaws? 9, 9. I feel like I'm speaking German. 9. 9 and BD. 9 and BD. So this is the alligator here. And this one here. So they're kind of facing opposite directions. Anyway, this alligator's jaws are open 8. This alligator's jaws are open 6. So what can we say? Shoot. Well, you can call it angle D. So this jaws are open wider. So this angle right here is wider. Can't call it angle D though. What can we call it? Angle BDC is greater than angle, ABD. So they put angle ABD question mark BDC. So ABD was the small one. So number 19 is less than. All that work just for less than. Now I kind of need that picture back with all the mess. There we go. Yuck. All right, 21. Okay, it says AB is 16. BC is 16. So we already got our jaws here. And ABD is half of angle ABC. So, what does that tell us? If ABD is half of ABC, what does that mean? If angle ABD is half of this angle, then what do we know about this angle? It's the same thing. These two angles are the same. So, and this side's the same. So the two alligators are both facing down on this one. So if we have the same mouth and the same angles, what can I say about these two guys? They're the same. So basically we have side angle side, the triangles are congruent. So AD and DC are the same, so that would be equal. That's probably the only time that happens on this assignment. I think everything else is less than or greater than. Just threw in a curveball. Okay, 23. Easy to do, kind of hard to remember. Find the range of possible lengths for the third side of a triangle with the two given sides. So, okay, let me do a little picture here to give a visual. So we got one side that's 3 and one that's 36. Okay, how long must this third side have to be? True.
33.
Okay, well,
34.
it's gotta be, well, it could be 33.1 or something. So it's gotta be bigger than 33, right? So it's gotta be bigger than the difference between these two. Because 33 plus 3, it's gotta be bigger than this. This plus this. So it's gotta be bigger than 33. But also, there's something else that we have to worry about.
Less than 36? Or
No,
less than 37?
no, you're kind of on the right track though. If we put the 36 and 3 together, it couldn't cover if it was 39, right? If the third side was 39. Like 36 and 3 wouldn't be big enough. So the third side has to be smaller than 39. So it's got to be bigger than 33 and smaller than 39. Here's the best way to write that. Okay, can somebody maybe help sum up like how we can get these numbers simply? 33, how does that relate to these two guys?
The 3 would have to be connected to the 33 for it to be a complete triangle.
Yeah, they add up to this, or you could say this minus this is 33. It's got to be bigger than the difference of these two numbers. So 36 minus 3 is 33. It's got to be bigger than that. And 39, it's got to be smaller than the sum of these two numbers. So that's where this number comes from. So the third side has to be bigger than the difference, so subtract. And it's got to be smaller than the sum, adding. Okay? It's easy to do, maybe hard to remember exactly how it works, but that's basically what those numbers are. This is the difference between the two sides, and this is the sum of the two sides. All right, so on 35, oh goodness, or 25 rather, it gives us letters. Because they wanted us to find the pattern. So the pattern is X has to be bigger than the difference of A and B. And it's got to be smaller than the sum of A and B. There is something that's a little bit wrong with what I wrote. Does anybody know what's wrong? Well, not the minus. What if A is the small side and B is the bigger side? And this would come out negative. That doesn't make sense. So how can we not make it come out negative?
What's that? Absolutely.
Absolute values. So that kind of puts a patch on it. So if you subtract in the wrong order, it makes it right still. Good thing that was an odd. Alright, looks like I assigned 27 and 29. The directions are kind of the same. Assume, find the range of possible values for x. Alright, so we're doing alligator draws again. So we're on 22 through 25, we're talking about one triangle. But on this section, we're talking about two different triangles. So it's a different thing, really. So it's alligator mouse again. Do you guys see the two jaws? One has one mark, the other jaw has two marks on it. The alligator on the left, it opens up to an A. The alligator on the right opens up to A plus 2. So, what do we know about those angles between the jaws? No. BC, is that smaller or bigger or the same as EF? Smaller. So what do we know about the angle between the jaws on the left triangle? It's smaller. The alligator on the left, jaws only open up A. The alligator on the right, jaws open up to A plus 2. So that means the angle on the right should be bigger than the angle on the left. Or the angle on the left is smaller than the angle on the right. So 2x minus 4 is less than 60. I think they just want you to solve for x, probably, yeah.
Sure, names, yeah, sure.
Yeah. I'm not going to make you guys do this, but on 27, x would have to be bigger than 2, because if you plugged 2 in there, you get 2 times 2 minus 4 is 0. You can't have a 0-degree angle. So the book put x is between 2 and 32, because you can't have 0 or negative angle. But we're just going to settle for the upper limit. X is less than 32. It's fine. On 29. It's kind of like a kite. You guys see the alligator jaws? Which way are they facing? Toward the left. The side in the middle is shared, and then that tells us that these outsides are the same length. So it kind of looks like this. Like these are teeth. You guys know what I'm drawing there? Eyeball. Eyeball. Alright. Well, shoot. This one's kind of tricky. You guys see the problem? They're not telling us what the angle is. They didn't tell us which of these angles is bigger. So how can we tell which angle is bigger? Okay, you can tell because it tells us something about the other two angles. So it it tells us the top and the bottom angles are the same. It puts an arc on both, so those are tied. But it says on the left angle, the bottom triangle's left angle is slightly bigger than the top triangle's left angle. So what does that tell us about the bottom triangle's right angle? Okay, if this angle right here uses a little bit more degrees than this angle right here, then what's that leave for this? Okay, if this is 44 and this is 43, this is using more degrees, so that's going to leave less for this one, because they have to add up to 180, right? All triangles, angles have to add up to 180. So if this is tied with this, but this one's a little more than this, that's going to leave a little bit less for this. So this angle is bigger than this angle. If this angle is bigger than this angle, what's that tell us about these two sides? This alligator's mouth is open a little bit wider, so the gap here is going to be a little bit bigger than the gap there. So 18 is greater than this, or this is less than 18. 2 minus 4x is less than 18. What happens on inequalities when you divide by a negative? All right, that's all she wrote.